So this is an easy question which I just wanted to do as a practice. A linked list cycle. Given the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, POS is used to denote the index of the node that tails next pointer is connected. Note that POS is not passed as a parameter. Return true if there is a cycle in the linked list, return false otherwise. So I would like to use a tortoise and a hare pointer system where one pointer is faster than the other, and so the faster pointer moves up 2 spaces while the slow pointer moves just 1 space and 1 place, and eventually if there is a cycle, the faster pointer will catch up with the slower pointer, while if there is not a cycle, it should directly end up towards a none. Any of them would just become a none. I think the faster pointer would become a none before the slower one, and then in that case we will just stop. So I think we will need to check the faster pointers next. We will need to check if the faster pointer as well as the faster pointer's next value is not null. Otherwise it may happen. So there are two cases where in the case where the list is actually ending, the faster pointer can be at the last node, so the next value of the faster pointer is null, so the loop should exit. In the second case, it's in the second last node and it will eventually go to the last node, and so when it is in the second last node, it will eventually go to the null node after the last node, and in that case as well it should come out of the loop and we can return false in that case. So I think that should be the main base cases to stop the loop. So we have the slow pointer equal to head and the faster pointer is equal to head as well, while fast and fast dot next is there. Now if the slow pointer is equal to the fast pointer, we should return a true directly, else we update the pointers. Fast is updated to the second pointer from its current second node from its current node. The slow pointer is updated to the next one, and if it does exit, we can return a false because there is no cycle. Am I missing something? Let's do a trial. So we are at 3 over here. Fast pointer goes to 0, slow pointer goes to 2, the next iteration fast pointer goes to 2, next slow pointer goes to 0, then fast to 4 minus 4 and slow to minus 4. In this case both of them are at this. The slow is equal to fast, return true. In a case where this goes to null, fast becomes this, slow becomes this, fast goes to null, slow becomes this 0, fast is having a null value, so it should come out over here and we return a false. Let's check this out. Okay, are there any edge cases that I need to look at? Number of nodes in the list is in the region of 0 to 10 to the power 4, so the input range is 10 to the power 4, so this works in order of n, mostly order of n by 2 because the faster pointer will catch up before the slow pointer goes to the end of the list, I think. And yeah. So there is also a case where a null pointer can be passed. So will this work in that case? Fast is a null. I think so it should pass. Let's test it out. We'll just send a null value over here. Position, there is no position. Does this work? Do I need to have a position? Position is -1 or variant index. Okay, I need to put in -1. Let's check this out. Okay, this works. Submit this. Okay, we have a wrong answer. Faster pointer is at null. Slower pointer becomes 2. I think the condition needs to be checked at the end, because we are starting from the same position, right? If we are starting from the same position, initially it will return a true. It should first go to the next pointer, next places, and then we should have a comparison. Will the condition need to be changed now? Let's see. 1, 2 normal case. It work. We go to the next pointers, 0 and 2. Check. In the case where fast becomes null, so we need to check if the fast pointer has become a null, and only then it should be equal to the slow, because if slow and fast are both becoming null, you can't return a true. Let's see now. Yeah, it worked. Okay, I think the condition needs to be checked at the end, because we need to start at the same positions, and so initially it will obviously return true. So I think that should be the most optimal case.